Welcome everyone to another video. We're back with the Yamaha B-6. I know it's been quite a while since we've worked on this. I haven't forgotten about it. I just had to take a break after what happened in the last video, losing some of those outputs, because it was not good. You know, it was one of my worst fears with this amplifier, which was to lose some of those very hard to get and very expensive output transistors. I feel like I've collected myself now and that we can see this project out to the end. That's not to say I haven't been doing anything. I've been working on a lot in the background around this to bring it back to life in a way that is cost effective, because this amplifier just is not worth the investment of buying these original transistors anymore. They are just too expensive. I'm not going to put that sort of money into this sort of a project. But anyway, let's get stuck in and I'll explain what all this is and how we're going to bring this thing back to life. Right, so this is all the work I've done in the background around this. I've been trying a lot of different things. I've got entire trays of transistors I've been experimenting with, trying to figure out how I'm going to do this. I was going to use this package type transistor, but I've decided not to at the moment. I want the bigger surface area just to try and get as close to the original transistors as I can. So I've decided to go with these Toshiba transistors, and these are TTA 0002 and TTC 0002, made in Japan. And honestly, I prefer newer transistors when they're not exotics like a VFET or something like that. Newer transistors tend to be cleaner, they haven't aged, and it's just going to be a better outcome overall. And the fact that these failed so easily does give me some concern about how good these are. And they are incredibly expensive, and I'm not going to pay... I've seen stupid prices, like up to $80 per transistor. And I lost 2 out of 4 on that channel, and all 4 are good on the other channel. So I am going to basically remove all of them. It's going to be the same on both sides. Like I said, I do not mix and match transistors. I will replace left channel, right channel to be identical. And how I am going to do that is I designed from the ground up these brackets, which are designed around this amplifier and mounting this specific transistor package. So basically how these work is they will lock in to these clamps and they will sit in like that. And the transistor sits proud by about 0.5 millimeter, and this will clamp down in the original position that these transistors sat in. And the general idea is there's these 2 notches here and here, which sit parallel to the die, which is the main area that generates the heat. And if you look at this holder, you've got a washer sitting above it, and there's a screw that's going to go down. So that's going to push down on those notches and lock this transistor against the heatsink and the thermal interface. I've custom made laser cut thermal interfaces, which are designed just for this also. And I think this is going to work really well. These are 3D printed. They are, you know, pretty flexible. They're printed in an onyx filament, so they have a very high temperature rating. They're not going to melt or anything, but they are flexible. But the point of them is not to be rigid in this direction. They just have to stay together and align the transistor. And then these bolts with the washers are going to really provide the clamping force across this entire die area. They are going to overhang a little bit at the top, but there's no heat at the top here. All the heat generation is in this center portion just here. So we have 8 of those. I've gone through all the transistors, and I think I've matched them about as good as I can. You don't really need to match the outputs, but I just do it because I can. These are all coming out, so we're replacing every one of them. I'm going to do half the amplifier and then the other half, just so I can try and keep the plate aligned while I'm fitting these brand new transistors. New thermal interfaces here, and we're going to just see what happens. Now, in regards to the amplifier, I pulled the outputs, I replaced the fuse, I checked for shorts. I couldn't really find anything else wrong, and it came out of protection fine. There was no abnormally high power consumption, so I believe there are no other issues in regards to the drivers or anything in this unit. So I think we just got away with a couple of outputs failing, which is quite odd in itself, but who knows, this whole thing is odd. So we are going to start fitting these new outputs. We're going to start on this side. I've already got one sitting in there just for test fitting, and then we're going to do the other side. We're going to start reassembling this thing. I'm going to do one other little mod also, and let's hope we can get it back to a working state that we had before and try to recalibrate and reset this thing with new output transistors. So I've got the left side just sitting in at the moment. I'll try and get some video here and there while I'm doing this. It's just a bit finicky, so it's a little bit hard to film. But I don't think I said it before, but these packages, I don't think if there was anything different about these, they would not fit and this would not work out. Like those screw holes right above them, that's really close. They barely sit on the metal plate and the legs are bent over right near the base, and I don't think we go any further than that either. And the overhang here, don't worry about that. I've checked it, but it does get very close to the main chassis of the amplifier when all this is reinstalled. It looks really good, but wow, it is a tight fit. Right, so got all the outputs installed. Everything is looking really good here. I actually did this yesterday, tensioned them, tightened them down. Then I came back and retightened them again just to make sure this is compressed as far as it was going to compress, and just made sure it was tight, not going to come loose again. Everything is looking fine there. I think we're about ready to move forward there. So I just want to address these two resistors in here and here on this side. So these power those two pre-drive boards, and if something goes wrong with this pre-drive, these will go out. The resistors that used to be in there, these are a special type of resistor that's actually a fuse built in. So these were 110 milliamp fuse rating plus a 22 ohm resistor rating, and one of them had been replaced at some point with a normal resistor. So this is the first time I'm going to be trying this, but I'm replacing them with a 22 ohm resistor plus a pico fuse. So these are single-use miniature fuses. So these ones are 125 milliamps. That's as close as I could get. But I found out that these are really important because if these pre-drives have a short in them, this is all that's going to stop them from completely flaring up and blowing everything out. So we're definitely going to fit these. And I made them about the same size as the originals. They should just drop in there. So I'm going to fit those. We can do some final pre-flight checks, and then we should be good to power this thing up. Right, so I got those little fuse resistors changed out. I'm just going to do some final pre-flight checks. I'm not looking for anything in particular around these readings other than something that's different from the rest. Just checking for shorts, basically, that would cause big issues if we fired this thing up. So one side failed, one side didn't. So I'm just comparing the left and right sides just to make sure we're getting similar readings across every leg, every pin, and it should mirror on both sides. If it doesn't, or we see a dead short, we've got problems. Excellent. Nothing on the outputs, no shorts. These ones might be a little bit different to check. Probes are not great. This is just a quick and dirty way of doing it. Like I said, I'm not comparing it to schematics or anything. Just looking for anything crazy. Because it is really unusual to not lose other components when you have a failure like this. Really weird. Looking good though. 421, 421, 367, 367. God, this is really consistent from side to side. 422, 423, 367. All right, I think we're done. I'm gonna connect everything back up again, turn down the bias because we have brand new transistors, and I think we're ready to connect power and hope nothing goes wrong. Right, so moment of truth. Everything is back together. Power supply is connected. I haven't touched the power supply. I've turned the bias all the way down just because I don't know what these transistors are going to act like. They should perform basically the same as the originals, but we'll tread carefully. So gonna plug this in. We'll keep an eye on the power consumption. I'll just be ready to unplug it if I have to. It should go up to about 100 watts and then it should drop down immediately if it's the same as it was before. Got the bias over here and let's just see what happens. Oh, relay click, that's good. Power consumption's right down, about where it would normally be, 17 watts. All right, I'm gonna just check if we have bias control. That's probably the main thing I wanna know, and the power consumption should come up as well. Yeah, definitely got bias. That side's fine. We should probably check the side that actually blew up. Power consumption coming up, whoa, way too much. We've got bias on both sides, so I think we're all right. I'm going to let this warm up and I'm going to run through the bias a few times, calibrate again, do the whole thing, and then I will we'll come back and maybe we'll hook it up to the audio analyzer. Don't have as much room on this bench, I'll figure something out. So back to the scene of the crime. This is giving me bad vibes because it's a lot of new stuff here, and it feels like we're back to where we started again. So I've got the large metal block which is dumping all the heat from the output transistors. I've got fans everywhere, I've got clamps holding it to the metal block. There's a lot going on here. Still using my external DAC. I've taped everything together so hopefully nothing comes loose or falls out. Do not want that to happen again after all that work. But I've already got a 5 volt RMS output coming out of the amplifier, and we're looking at 0.009% distortion. 0.009% distortion. Channels are looking really good again. Same as what we did in the last video. I'm going to just cycle a 20 hertz to 20 kilohertz signal over and over and over again, just to cycle the transistors, look for any weird oscillations or unusual things. Then we're going to move into load testing and hopefully we can close this out and start to reassemble this thing. That's the hope anyway. Right, so I knew something was going to bite me in the butt with this, and these new transistors work fine, more or less. The issue is that this amplifier with its crazy rail switching system, so it goes from a 36 volt rail up to a 76 volt rail, and there's a transition period that it goes through when it switches from one rail to the other. These new transistors seem to be more sensitive, and that is causing an issue where their power demands are increasing before the rail switching takes place. So there is like a gradual increase in distortion, and that is causing a lot of problems here. So I need to figure this out, but I'll just show you what actually happens. So if I bring this up to say 10 volts, we can see that distortion's really low, 0.005, and what I found is about 12 volts RMS is as much as it'll take, and we're down to 0.004. If I go beyond that, now the distortion is coming up, and I'm assuming it's because there's insufficient rail voltage for the output, and it's just going to keep increasing until we'll see the rail voltage increase in a second. And there we go. Distortion's gone. Rail voltage is switched up to 72 volts. And yeah, there's like this weird period in the middle where the distortion is, you know, coming down and the rail is like half switched over. I don't know exactly how this works. Obviously, it's a fixed set point, might be a resistor or something in the amplifier. I need to go through the schematics and work out exactly what triggers this switching point, and we're going to have to make some sort of an adjustment to be able to use these newer transistors. So let me go to the schematic and I'll see what I can find. Right, so it is now roughly 2 weeks later. I have been spending many nights trying to figure this out. I'm really pushing the boundaries of what I understand about electronics and amplifier design, switching rails. It's really above my pay grade. I'm trying to learn, but I'm not an expert. I don't think anyone's an expert with these amplifiers. Long story short, I sorted out the rail switching issue. Turns out it wasn't actually an issue, but it's nice to know that we can do that. So I'll overlay the schematic of the amplifier, and I identified 2 resistors that go up to the power rail, and you can change the value of that resistor to adjust the transition point from the 36 volt rail to the 76 volt rail. And I went from 33k ohms up to 47k ohms is where I found the sort of happy place for this amplifier. The rabbit hole went a lot deeper than that though. I thought I had fixed it. I put everything back together and it turns out the issue is still there, but now it's on the 76 volt rail. My God, this amplifier is nuts. Anyway, so I'll just show you where the resistors are. There's one just here, and there is one at the top here, and they feed into these op amps here, which are actually comparators, which are being used to do the feedback for the rail switching. Now, I played around with both sides of these comparators. One side goes to the output, which is tapped off the speaker terminals, and the other side goes to the power rail. And I played around with both. I played around with a lot of different things. I learned a lot, but ultimately I was chasing my tail and I was completely off track of what was actually wrong with this amplifier. Well, it's still wrong. It's not bad, but it's just... Let me explain. Let me show you the rail switching first. So I'm going to bring this up and we'll get back to where we were. So here we are around that 12 volt mark, 32 volts on the rail for the output transistors. Now, let me show you what happens. Look at that distortion. We're down to 0.04. Now I'm going to cross over into that point of where we were having issues. You can see it's getting down into 31 volts. And there we go. We're switching up immediately. Distortion is still low. And we're jumping up already, straight up. And look at that, we're already up to 72 volts. We didn't even get down to the 30 volt range. We were doing really well. Distortion is really low through the whole transition period. So we have fixed the issue, but we haven't fixed the issue. We have compensated for another issue, right? So now I'm going to show you what's happening now, because I should have done this in hindsight. I should have done this at the beginning. I should have gone all the way up to maximum power, but I didn't want to do that while there was an issue. I should have tested it because then I would have known there was more than one problem. So we're going to keep running. Just to show you what's going on, this top trace is the DC input for the output transistors. So this is just sort of showing ripple or noise on the power rail for the output transistors. And this is the actual output signal. So when this gets up to around 27 volts, we're going to see something happen here. And this is how I finally figured out well, I haven't figured out exactly what's wrong, but I know where the problem is now. So I'm going to start bringing this up, and you can see this in the rail switching period. You can see this trace jumping up, and it's going to re-level itself. There we go. We're up into the high voltage rail now. Everything's good there. So we can go up to about 27-ish volts and everything is fine. 0.004% distortion. Ripple is under control on the DC rail. And if I go up again, still okay. What are we at? 29 volts. Okay, so a little bit higher this time. Go up one more, and there it is. Distortion has come up. There's this spike in noise as well. If I go down, so hold it right on that point. Yeah, so 0.004% distortion, rail is happy. I got one more, bam. Distortion and noise on the power supply. So through trial and error, I should have found this in the beginning. I should have gone straight to the supply rail, but you know, hindsight always comes around and bites you. I played around with a lot of different things. I tried changing the base resistor on the output transistors, lots of different things, and I think an issue has happened in between all this stuff, and it isn't actually these new output transistors is what I can tell. It looks like there is a problem in the triac power supply. And problem, I don't know. Like we're still what are we looking at? If we go up to like 35, well, look at that ripple, Jesus, or noise, whatever you want to call it. So we're still at 0.03% distortion. It's not crazy bad, but you know, most techs would just send the amplifier like this and consider it done. I'm not most average techs or people. I am very fastidious and meticulous, and I don't think it's an acceptable amount of distortion, especially compared to what we had before. We know this amplifier will do 0.003% distortion at maximum power. So there is something going on in the triac power supply section here. And I sort of confirmed that by playing with these trim pots while it was loaded, and I did see the distortion figures change and the noise changed also. So where are we at the moment? I have a lot of projects that have been on the back burner because of this and how long this has gone on for, and they are really exciting preamplifiers, power amplifiers. There's a lot of things. I do not know enough about triac power supplies and whatnot to be able to fault find this reliably, I think. And this will only happen under heavy loads. And it affects two different power rails at different levels of power consumption. So I can only assume that it is based on current and not total power, because the 36 volt rail and the 76 volt rail are doing the exact same thing, probably at around the same current draw. How that works with the triac at different power consumptions, I don't know, because we're looking at 3 times the power consumption on the other rail compared to the 36 volt rail. So yeah, long story short, I've decided I'm going to put this back together for now. The amplifier works really well up to 100 watts. There's just a bit more distortion than I would like past 100 watts, but I need my bench space back so I can work on some of these other amplifiers. And then we're going to come back to this once I feel like I know a little bit more about this power supply, because I basically wasted 2 weeks chasing my tail because I do not know enough about this stuff. I probably should have gone to this in the beginning, considering it was on both channels, and looked at the power supply. But because we changed all the transistors at the same time, everything just sort of came together and nothing made sense. So live and learn. So I'm going to just do some final calibrations on the shut up multimeter on the power supply, and then I'm going to start reassembling this thing, and we're just going to put it back together for the time being. I'm not done. We'll come back and we'll figure out what is wrong with this, but I have to get a game plan together on how I can load this thing without this connected, because I want to make sure there is absolutely nothing in this that is feeding back and causing weird problems. This is supposed to be able to run completely independent. So I should be able to put this on my load banks and power this thing up independently, but I've got to figure out a way to do that. That's a whole thing. We will come back to it. So let's just reassemble this for the time being. It'll work great. You wouldn't even hear the distortion, but for a flagship Yamaha product, I would expect it to be better. Anyway, let's get this back together. Oh, I wish I didn't leave this thing apart for so long. I'm trying to reverse everything and put this back together in what seems sensible and looking at a few pictures online. I think I've got it worked out and I'm slowly rebuilding this. Just wanted to show you also, I made new speaker binding posts. This is all 3D printed in Onyx with really nice banana jacks, so no more push pin terminals like I do on most of my amplifiers. So I'm going to try and get this board to mount back in here. This power switch has been an absolute nightmare. I've replaced the wiring that went to the triac board because there is absolutely nothing left of this thing. So I've got to replace that also, but I left this wire extra long so I can solder that to the board once this is all assembled. Seems to be the best way to do this, so let's keep going. And here we are with the pyramid mostly assembled. I'm just rechecking the adjustments while it's partially assembled, just to prove it to everyone, because someone's going to say that I didn't set up the triac correctly. Here we are, 76 volts on the supply rail, 60 millivolts on the triac. Everything is perfect here. Who knows, something might happen with all this reassembled with proper shielding. I personally don't think it's going to solve that distortion issue, but we can only hope. So I'm just going to finish the final adjustments on this before I put the lid back on, and then we'll do the final bias adjustments with it mostly sealed up, and we'll see what happens. We'll do some final load testing. And here we are doing the bias adjustment. So the service manual calls for 2.5 millivolts. Very sensitive. So basically got it upside down. I've got the cover just sitting over the top of it. And I'm just putting my probe through the holes, and I can reach all the blue trim pots in here. That's working really well. Bias seems quite stable, but the adjustment itself is very, very sensitive. So I'm basically going to run through this maybe 5 cycles over a couple of hours. Ideally, it should be flipped the other way because the temperature is going to change, but this is about the best I can do. So I'm just going to do this when we do the DC offset, and we should be all good. And finally, here we are with the DC offset adjustments straight off the speaker terminals. Very stable now that most of the covers are on. It is very thermally sensitive, so when it was on an open bench before, it was jumping all over the place. So I'm happy with that. I think we're going to set this thing up and do some final load testing. So we're just going to go up through all the power ranges again and check this thing over, see if it's better or worse. Don't know what we're going to get. So yeah, let's just go up. We'll go up to about 1 watt per channel. So 0.016% distortion. Go up to about 10 volts. 0.005%, 0.004%. All right, so we'll just go up through the wattage ranges. So 25 watts per channel, 0.003% distortion. Very nice. 50 watts per channel, 0.003. And just got to rescale these ranges because we're going to be going up higher now. So we'll go up to where it was having issues before. So this is about 100 watts a channel, 0.003. Still hanging in there. So we're up to 150 watts a channel, 0.004%, 0.005. So it's going up a little bit. I think we're right there now, but it's higher than it was before. And there it is now, 0.02%. And run up to about max power. So we're just past 200 watts a channel, 0.04, 0.06. All right, clipping point. That's clipping. So about 220 to 230 watts per channel at 0.06%. And its rated power, we're looking at 0.03%. We know it does better than that, so it's not perfect. But it is not doing it around the same point as it was before, which is quite odd. So yeah, something has changed now that's all reassembled and it's shielded properly. But at the same time, we've hit those really insane figures with it sitting on an open bench on the other side of the room. All right, it's all looking really good. I think what we're going to do now is I'll set up the thermal camera and we'll do a bit of a video watching this pyramid actually heat up. Like, so the heat, the transistors are down here, so the heat's going to sink up, and I'm curious how this thing actually tolerates a sustained load and if it's actually capable of soaking up a decent amount of power. So yeah, I'll rejig all this and we'll come back. Well, here we are at the finish line. It has been a very long journey, and I'm glad to put this one aside for a little while. Very surprised. This die-cast metal enclosure actually can hold its own. It has a lot of thermal mass and it can suck up a lot more heat than I gave this thing credit for. So that was about a 100-watt load. And in the first instance, I did it for about 4 minutes to 5 minutes. I was starting to get really uncomfortable because it was, pulling about 550 watts from the wall and it was going somewhere and it wasn't all going into audio signals. So there was a lot of heat building up in this thing and I was worried something was going to happen, but it proved me wrong. It seems to be able to put out its power figures for a significant amount of time and it is not as fragile as I expected it to be. So yeah, you saw some footage from the thermal camera. Pretty cool. Just thought we'd have a look at that to see how the heat dissipates from the output transistors through this enclosure. It is still a hot box though, and you need to be careful with these things. But I don't think it's to do with the top section. It's more to do with the pre-drive and everything on the underside, which is why I put some much bigger feet on the bottom of this thing, which will hopefully space it out a little bit and give it a bit more breathing room on the bottom. What do I think of this amplifier? Well, it is a very cool piece of history, but like all Yamaha products, it has very good distortion figures, and I don't really think it does anything that you can't get on some other Yamaha flagship products that are much more proven in reliability and not a basket case to fix when things go wrong. So yes, very cool for a collection if you're a Yamaha collector. definitely belongs in a museum, but I definitely wouldn't be seeking one of these things out. I don't think, unless you really like to punish yourself with very long repair periods, or you want to learn a lot about Yamaha's history. So yeah, we will probably come back to this in the future at some point. I don't know when. We'll see what happens. I think the main thing I need is I need a new oscilloscope, like a modern version that also does FFT slash spectrum audio analysis. And I need to be able to really diagnose the triac power supply, because I'm 99% sure that is where the power supply noise is coming from. And we'll circle back to that. Any comments, if you're still with me at this point in the video? Would love to hear some feedback on what people think this could be. But, 150 watts at 0.003%, only up to 0.05% at 200 watts. It's really not anything worth worrying about, but the sadistic part of me wants to know what is causing that, because it did start after we had that overload that blew the fuse, so it may have damaged something else in the triac. Hopefully not that unobtainium blue IC. Anything else we can probably sort out, but yeah, something for the future. We've got a lot of crazy projects coming up that we need to dive into, so let's put this aside for a while. I hope you enjoyed this video and this series, and I will see you in the next video.